In this video, we will discuss basic dilations. Dilations from the origin. Now, what is a dilation? A dilation is a change in size where you are not changing the shape. So a dilation could mean that the shape is getting bigger than the original. Okay, so this would be a dilation if if the red triangle was the original preimage and the blue triangle is the image, then you can imagine that it got bigger. So that would be a dilation. But you could also look at it the other way around. A dilation can be a shrink as well. If you start with a larger image and it gets smaller, then that is also considered to be a dilation. You must know the concept of scale factor. Say if the dilation is a shrink, where you're going from a larger figure to a smaller figure, the scale factor is going to be less than 1. So imagine that the smaller triangle is half the size of the original triangle. Then the scale factor would be 1/2. Alright, so imagine that this side of the triangle was length 10. Then this side of the triangle, the new triangle, would be length 5. Alright, that's how scale factor works. If this side of the triangle were 12, then the new length right here would be 6. On the other hand, if the dilation was one where the triangle is getting bigger, like if this is the preimage and this is the image, then now, for example, the scale factor might be 2. So this is where if this side were length 3, then this side would be length 6. In addition, every dilation can be looked at as radiating from a single point called the center of dilation. So imagine that this point is the center of dilation. Again, I'm going to talk about scale factor. I'm going to use the letter K to stand in for the scale factor. If the scale factor is 2, then before I talked about the fact that the lengths of the sides of the triangle will now double. So if this were 3, this would be 6. But now I want to talk about the fact that if the original distance, alright, imagining that the smaller triangle is the preimage, if this distance is 4, alright, the distance from the center of dilation, then if I look at the corresponding point on the new triangle, that distance from the center of dilation will be double. So that will be 8. Okay, so if this distance, here, let me switch to green. Alright, from the center to this point, alright, imagine that that distance was 8. Then the distance from the center of dilation to the new point, okay, this distance right here would be 16. Alright, so that's another way to think about dilation. I could use the same picture to imagine a dilation that is a shrink. So if the blue triangle is the preimage, you know, the original, and the pink triangle is the image, you know, the new resulting picture, then obviously this is shrinking. So let's imagine again that the scale factor is 1/2. So this time we would say to ourselves, okay, looking at this point, if this original distance from the center was, let's say, 12, then the new distance from the center would be 6. Okay, so it's all about the scale factor. So look at problem number 1. We are given this preimage, and we're going to do a dilation with the origin as the center. We're told that the scale factor is 1/2. Right away we know this will be a shrink because the scale factor is less than 1. So when the center of dilation is 0, 0, it's very simple to work with the coordinates, because if the original point is x comma y, all you have to do is multiply each coordinate by the scale factor. So the new point, the image in this case, would be 1/2 x comma 1/2 y. You just multiply by the scale factor. So let's look at the original coordinates of this picture. So let's see. For point A is 0 comma 4, and point B is 4 comma 4, and point C is 4 comma 2. Am I counting right? 3, 4. Yeah. Alright, so multiplying these by 1/2, that's going to give me that A prime is 0 comma 2, and B prime is 2 comma 2, and C prime is 2 comma 1. Okay, so 0 comma 2, and 2 comma 2, and 2 comma 1. So this teeny tiny triangle right here is going to be the image after the dilation. And we'll squeeze in a little A prime, B prime, and C prime. Okay, looking at problem number 2, this time the scale factor is 3/2, also known as 1.5. Okay, so let's again write down the original coordinates. Alright, so point P is the point -4 comma -2, and point Q is -1 comma -1, and point R is -4 comma -4. That's not a very good -4. If you multiply each of these coordinates by 1.5, then this is what you get. So P prime is -6 comma -3, and Q prime is -1.5 comma -1.5. Should be right about here. And R prime is -6 comma -6, which would be right here. So that's what your dilation would look like. Notice that it is bigger than the original because the scale factor is bigger than 1.5. Let's do the same thing for problem number 3. The coordinates of point J are 2 comma 4, and point K, that's 1 comma 1, and point L, that's 4 comma 0. The scale factor is 2. So all we have to do is multiply all of the coordinates by 2. So that's going to make this 4 comma 8, 2 comma 2, and 8 comma 0. Alright, so here we go. 4 comma 8 is going to be right here. So that'll be our J prime. 2 comma 2 is going to be right here. Okay, so that is K prime. And 8 comma 0 is right here. So that is L prime. So here's your dilated image, twice as big as the preimage. Okay, in problem number 4, we are shown a dilation. Here we have the image and the preimage graphed. We're told that the center of dilation is the origin, 0 comma 0. you see that the smaller image has the primes. So that's the image. So this is a shrink. It went from being this larger quadrilateral as the original, and then it became the smaller quadrilateral. So we know that this is going to be a scale factor that is less than 1. So let's target a couple specific points to help us figure out what the scale factor is. Let's use point P and point M. Okay, so point M, the original point M has coordinates of 3, 3. Okay, now the image of point M, M prime, has the coordinates 1, 1. So what would I have to multiply by to turn 3 into 1? Hopefully you're thinking 1/3. If I multiplied 1/3 times each of these coordinates, that's the same as dividing by 3, and I would get 1. So it looks like the scale factor is going to be 1/3. Okay, let's look at one more point just to verify. Let's look at point P. The original point P is -6, 6. So we have -6, 6. All right. Now, according according to our hypothesis, the scale factor is 1/3. So what would happen if I multiplied each of these by 1/3? In other words, divided by 3. Well, this would become -2, +2. All right. So look, -2, +2 is right here, and that is P prime. So it looks like our hypothesis is correct. Okay, so that means that the rule is xy is going to become 1/3 x, 1/3 y, scale factor of 1/3. So according to this rule, the image of this point, all right, if I divided each of these by 3, that would be 2, -4, just dividing by 3. Okay, according to the same rule, what would be the pre-image of this point? Okay, well, the pre-image, I have to do the opposite and multiply by 3. Remember, looking at the rule, the x, y, that's the pre-image. The image is 1/3 x, 1/3 y. So we are being asked to find x, y, and we're being told that the image is 6, -12. So comparing these two, see how the 6 is in the same spot as 1/3 x? That means the 1/3 x must equal 6. See how the -12 is in the same position as 1/3 y? That means 1/3 y equals -12. And we're being asked to solve for x and y, the pre-image. So how would we do that? Of course, like I said, we would multiply by 3. Okay, and here's how that would look algebraically. And again, over here, we would multiply by 3. That's how you would solve for y, because these will now cancel out. All right, so that's why we would get x is equal to 18 and y is equal to -36. Okay, so that means that the pre-image would be 18, -36. In problem number 5, we are given a dilation with a scale factor of 4.5, and these are the original points, the coordinates of the pre-image, and we're being asked for the coordinates of the image. So if the scale factor is 4.5, that means we just need to multiply all of these coordinates by 4.5. 4.5 times -1 is simply -4.5. 4.5 times 0 is 0. Alright, again, negative 4.5. 4.5 times 1 is 4.5. Okay, and another 4.5, and again you get 0. So that's the answer to number 5. For number 6, we are being asked for a rule that's going to be the dilation, most likely, that's going to convert UKF to U prime, K prime, F prime. Okay, let's look, let's make a hypothesis that we're dealing with a dilation, and let's hunt for the scale factor. So let's focus on these coordinates right here. 2 becomes a 3. So the question is, what would you have to multiply by? In other words, if I did 2 times what scale factor would give me 3? Well, if I wanted to find out what this scale factor, this k, was, I would simply divide both sides by 2. So that would give me a scale factor of k is equal to 3 over 2, which is also equal to 1.5. Alright, so let's test our hypothesis. If this is a dilation, multiplying all of these coordinates by 1.5 should give me the new coordinates. Okay, so if I do negative 2 times 1.5, that does turn out to be negative 3. Negative 1 times 1.5 is negative 1.5. Of course, 0 times 1.5 is 0. We already did 2 and 3. Those are the same as we already did, so don't need to worry about that. And in fact, 2 becoming negative 3, we already spoke about that as well. Alright, so this is a dilation with a scale factor of 1.5. So the rule would be that a general point xy is going to become, I could write 1.5x comma 1.5y. Or I could use the 3 over 2 if I wanted to. Okay, I could say (3 over 2x, comma 3 over 2y). Either way is fine. All right, let's do that one more time. Again, I'm guessing dilation, and at a glance, if 1 becomes 1.5, and so I'm thinking 1 times what scale factor would equal 1.5, it's easy to see that that would once again be a scale factor of 1.5. You know, technically you could sit here and go divide by 1 on both sides, blah. But hopefully common sense is working for you there. Okay, now, so I'm betting this is going to be the same thing. So again, if I check each one of these using a scale factor of 1.5, if I do negative 1 times 1.5, that is negative 1.5. So that checks out. Negative 2 times 1.5 is negative 3. We saw that on the previous problem. We just talked about this. 3 times 4.5. Okay, let me check that on my calculator. Well, yes, 3 times 1.5 is indeed 4.5. Okay, and of course 0 times 1.5 is 0. So it checks out, which means that the rule is the same as it was on the last problem. xy became 1.5x comma 1.5y. Okay, the rest of these problems will be a review of not only dilations but rotations and reflections and even translations. So this will be a nice review. When we talk about the line y equals x, that is a diagonal line at a 45-degree angle going up 1, right 1. Okay, so this is the reflection line. So if I want to find the image of triangle ABC, what I could do is just count squares diagonally. Now look at point A. It is 1.5 squares diagonally away from the reflection line. So there's half a square and there's one more. Alright, so this should be A prime. Okay, how about point B? Point B is 1, 2, 3 diagonal squares away. So if I go 1, 2, 3 squares diagonally on the other side, that should be the point B prime, the image. And now C. Point C diagonally is 1, 2, 3 and a half. So there's the half. And now I'll go my 1, 2, 3. And there is the point C prime. Okay, so your image is going to look like this. Alright, it looks a little janky trying to draw it with this bamboo tablet, but you're going to forgive me. Now this is one of those rules that you should have memorized. When you reflect over the line y equals x, all that happens is you switch x and y. So this is going to become y comma x. Okay, memorize this rule if you have not already done so. Now I said this was review, but I'm not sure we've talked about one like problem number 9 before. If we do a vertical stretch by a factor of 3, we are only stretching the y value. So the new coordinate should be x, comma, and then it should be 3y, because we're just multiplying all the y values by 3. So for example, if the coordinates of A are -1, sorry, that's not what it is at all. Coordinates of A are 2, -1, and the coordinates of B are 5, -1, and the coordinates of C are 5, -2. If I do a vertical stretch by a factor of 3, that's going to affect the y value only. So A prime should be 2, so I'm multiplying all of these y values by 3. So this should be 2, -3. And then B prime, the 5 is going to stay the same, and then multiply by -3. And for C prime, again, the 5 is going to stay the same, and multiply it by 3. So that's going to be -6. So this should be my vertical stretch. So 2, -3, alright, is going to be my A prime. 5, -3 is my B prime. And 5, -6, which is going to be off the graph. Right? 1, 2, 3. Okay, so that's going to be here. Ha! Why is that prime so far away? Anyway, draw this, and that's your vertical stretch. Alright, again, number 10 involves a rule that you should have memorized. When you're dealing with a 90-degree rotation, whether it's clockwise or counterclockwise, what you have is the x and y are trading places. That's not the end of the story, but that's the beginning of the story. So it's going to be y first and x second. Now, depending on whether it's a clockwise rotation or a counterclockwise rotation, determines whether the x value is going to change signs or if the y value is going to change signs. When it's a clockwise rotation, 90 degrees, the x value changes signs. When it's counterclockwise, 90 degrees, the y value changes signs. So I'm going to put a little negative sign right here to indicate that. So this will be the rule, and I just want you to memorize that. Okay, so again, I'm just going to write down the coordinates of A, B, and C. All right, and there they are. And now let's figure out what the image of each point will be, A prime, B prime, C prime. Now remember, the y value is going to end up first, and it's going to change signs. So let's start with the y values. So see this -1 is going to go first and become a +1. This -1 is going to go first and become +1. This -2 is going to go first and become +2. Okay, now the x value comes second, and it does not change signs. So I will have a 2, a 5, and a 5. So I'm just going to plot these, and that's it. So 1, 2, 1, 5, and 2, 5. And there it is. Okay, this last one is a translation, down 2 and left 5. When I write the rule, I have to do the left 5 first because that's the x coordinate. So that's going to be x -5 because it's to the left, and down 2 means y values -2. Okay, but drawing the image is very straightforward. So we'll just take one point at a time, and we will go left 5, down 2. So here I go, left 5 and down 2. Okay, that will be A prime. Okay, similarly, B prime will end up here, and C prime will end up here. Okay, so the whole triangle moved left 5 and down 2. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.